The number below is in binary 2's complement format. We want to write the decimal value for it. To do this, there's a couple of steps that we're going to follow and outline, and this applies for anything like this. If we have something that starts with a 0, it's going to be opposite. So step 1 is to identify the first index, or kind of the last index. So identify the first, which is going to be this right here. If it's a 1, it's going to mean it's an odd number. If it's a 0, it's going to mean it's a positive number, or not an odd number, sorry, that's a negative number. So 1 is negative, 0 is positive. So since we have a 1 here, we know that it's going to be a negative number. Step 2 is to flip the bits. So we have all 1s and then a 0. This means that when we flip our bits, it's going to be 0, 0, 0, 0, 0, 0, 0. So we have 1, 2, 3, 4, 5, 6, 7, and then we have a last 1 here. Step 3 is going to be to add 1. So we're just going to add 1 to this. And when we add in binary, we know 0 and or 1 and a 1 is going to be a 0, and then it's going to carry a 1 over. So we have our sum, which is 0, and our carry, which is 1. It's going to become a 1, and then we're just going to add the rest of these like this. We have 1, 2, 3, 4, 5, 6, 7. I forgot a 0 here. So we have 8 here. Now step 4 is to just finish. Let's actually do that in a different color. So step 4 is going to be our last, and it's basically just, you have your 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, and so on and so forth, 2 to the power of n, right? And so you're going to multiply whatever you have here, and we'll just go like this, and then we're going to add it together. So if we just do the first or last 3, we have 2 to the power of 0, which is 0, 2 to the power of 1 times 1 is going to be 2, 2 to the power of 2 times 0 is 0, and then the rest of these are going to be 0 as well. So we know we have this 0, and we know from earlier it's a negative. So our answer, I'll write this as step 5, is going to be a negative 2. And that's how we would look at this problem and anything like it for 2's complement, writing it from the binaries to complement format.